Hey, it's Clay. This is going to be another video. This time we're going to be talking about compression, specifically a guitar player's guide to compression. I think that for a lot of players, compression is a kind of a mysterious thing that gets brought up a lot, and unless you've done some recording or some studying up on it, it doesn't really make a lot of sense to a lot of people. So I wanted to kind of give you the very basics of what compression is, what a compressor does, and then how that is applicable to you as a guitar player to get better sounds. So let's start off with what is compression. Compression is pretty simple. It is taking your signal and it is reducing the dynamic range. So what does that mean? Well, when you make a guitar signal or any type of signal, could be a voice, could be a bass, could be a drum hit, you have soft things and you have loud things. The dynamic range is the difference between the softest and the loudest. So when you reduce dynamic range, so let's say that your softest is 1 and your loudest is 10. If you reduce dynamic range, that would be bringing your soft up to 3 and you're bringing your 10 down to 7. Your dynamic range is reduced. That's what a compressor does. And it does this in two ways. On one hand, it brings your loudest signals down. That is probably the biggest thing that a compressor does, is it limits your loud. It brings all of your loud signals, and whenever it gets past a certain point, it says no further, and it cuts the signal back. And then it boosts everything else remaining left over. So therefore, your high end is getting brought down, and then everything else is getting brought up, which most effectively brings up your lows, your quiet parts. So that is the basics of compression. Now let's talk about compressor tools. Part of the confusion, I think, is that compressors all look very different, and not all of them give you a lot of good visual cues as to what is happening, and compression can be very subtle. So let's kind of make a very obvious example I made of a guitar. I have two mics set up. We're just going to focus on this guy right here. So let's go ahead and... Actually, I lied. We're going to focus first track right here. So let's just go ahead and remove all the other tracks so nothing is confusing us. This is in a DAW, digital audio workstation, and the only reason I'm doing this is because it provides a really handy visual example. Okay, so this is the signal, an audio signal. Let's just listen to it for 1 second. Just me playing some clean guitar. You can see that the signal goes all over the place. Now, if we really zoom in, this is one hit of the guitar. You can see there's a little bit of stuff right here. These peaks that don't go very far from this middle line are quiet. And then the closer it gets to the edge, or the further away from the middle that it gets, the louder it is. So, for example, this hit right here is loud, and you can see it fades out. Let's just listen to that. So there's just one little guitar hit there. You can hear it. As it sustains, the signal fades out and it gets quieter. But the transient, the attack, the initial time when the pick hits the string is very loud. So, this is something where some compression would be really nice. A clean guitar signal has a lot of spiky transients. When you hear that, you're talking about these types of things, right? When the pick hits, it makes a very, very loud, percussive, spiky noise, and it's a lot louder than the rest of the signal. So, I have a compressor pulled up here. Compressors come in a lot of different shapes and sizes. I am going to use this one in particular, though, because it gives you a very nice visual representation of what's going on here in this middle section. So, there are a couple things to pay attention to. Number one is threshold. Threshold is probably one of the most important aspects of a compressor. Even if your compressor doesn't have threshold on it, there will be some sort of threshold. It may just be called something else. But what threshold is if we go back to, it says that whenever your audio signal passes a certain point of loudness, so for example, we used a scale of 1 to 10 before, whenever it gets to 6 or higher, then it's going to start compressing. It's going to start limiting the signal. Now, when we're talking about here on this in a DAW, you actually start at very negative, and then you go up towards 0. So you can see down here, it starts at negative 42, goes all the way up to 0, and goes up to plus 12. It's kind of, I'm not going to get into that right now. But on this graph, you can see when I move this threshold, this little green thing starts moving. This gives you a visual representation. So if I have 0 threshold, this would be actually impossible to pass this threshold. You know, this is, we're talking about negative 17. So these are audio levels, but the basic idea is that as I pull this down, it will become a lot easier for the signal to pass the threshold. If we go back to clip and let it play for a second. So I'm just going to mute that so you can't hear it. But the important part here to note is that you have these little parts that are exceeding the threshold. If I bring this down even a little further. So now anything that is loud enough to go beyond this range, so anything that is louder than negative 17, anything that is louder than negative 20 decibels is going to exceed the threshold, and then the compressor is going to compress that signal. Anything softer than negative 18 will not trigger the compressor to work. Okay, that's threshold. Now the next key point is ratio. Ratio is it's a x to 1. What that means is whenever part of your signal crosses over the threshold, how hard do we compress it? You could have a really, really high ratio. That would basically be like a hard filter. So anything that passes the threshold is going to be cut off almost entirely. You could have a very low ratio, like 2 to 1. That means that it's only going to be reduced or compressed a little bit. So let's go ahead and listen to this a little bit, and I'm in settings. At this level, there is quite a bit of the signal that is exceeding our threshold of negative 15, but it's a 2 to 1 ratio, which is very light compression, so you're probably not going to hear a lot. So I hope you could hear that. But what you should be hearing, I was toggling it on and off here a little bit, and I was also playing with the amount of ratio. Whenever you have a high ratio, it is really going to squash the signal. So whenever it exceeds that threshold, it's going to squash it down. So that's kind of some of the basics. There are other. I'm going to pull out a different compression plugin. This is the stock one that comes with Reaper, and it's very, very good. You have the attack and release. That's very important. What that does is it says once the signal exceeds the compression level, how quickly does the compressor start to compress per the ratio. So a very fast attack will give you that very squishy sound. A very slow attack will feel a little bit more kind of subtle and natural. And then release says once it goes back under the threshold, how quickly do we let it go and stop compressing? And a fast release will, again, give you a lot of that squashed feel. But then if you have a very slow release, then you actually can create some pseudo sustain because basically what you're doing is you are buffing up the signal. And then you are, even though the signal has gone below the threshold, you are continuing to compress it and give it a little bit of pseudo sustain. So I'm just going to, on this compressor, the threshold is over here. And then it doesn't have the nice visual indication, but it does have this red line right here. So whenever the red line triggers, whenever something comes up in red and it'll have a number, it means that the signal is being compressed by that amount. We're just going to do a 4 to 1 ratio. And I'm just going to play with some different numbers so hopefully you can hear this in action. this point, nothing is being compressed whatsoever. Off. On. Very, very heavy ratio and a pretty heavy threshold. A lot of compression going on. The pick attack is very squashed and squelched down. Really long release to increase some sustain. Okay, so that was kind of an extreme example. I had an extremely high ratio and a pretty low threshold. I mean, these are extreme examples so you can really hear what's going on. Typically, I would use compression a lot more subtly at settings kind of like this. More medium attack and release, more moderate ratio, more moderate threshold. So that is kind of some basics about compression. Now I want to talk a little bit more about guitar playing. So you can see on this example, this is a very clean guitar. You can see that the wavelengths are really spiking all over the place. Now I played around with some of the settings with the amp while I was doing it, so that's why this part gets a little bit louder. But I want to draw your attention over to this part, because this is when I went to the Overdrive channel. Let's listen to that. Okay, so there are some level differences there. The clean part was just flat out louder. But if you will notice, if I zoom in over here, this signal is clean, and it is relatively uncompressed, just as it is. So it could use some compression, because you have a lot of peaks and valleys indicating there is a huge dynamic range. So your volume is coming kind of in and out. When you go to an overdriven sound, you notice there's much less dynamic range. The peaks are a lot closer together. The sound is just a lot more even. That is because a guitar tube amp will provide natural compression when you send it into overdrive. That is just one of the things that overdrive does. It involves compression. And if you think about it, it makes sense, because what you're doing on the amplifier is you are taking, I'm going to try to show this visually. So let's say that this line right here is the volume knob on your deluxe reverb ratio. This is 0 and this is 10. So what happens is you can bring your up 1, 2, 3, 4, 5. Okay, so at this point, what happens is your signal doesn't continue to get any louder. It just starts to overdrive. So in terms of volume, you aren't gaining any more volume when you go up to these last 3 numbers, even though this signal it actually stays, but it just starts to clip and compress more and gets overdriven. When you boost the front end of an overdriven amp, you don't get more volume, you get more gain. And so compression, one of the reasons why playing with overdrive is so much fun is because it has all of that natural compression going on in the tubes. So be aware of that. When you are dealing with an overdriven signal, you have a lot of natural compression going on. You probably don't need a lot of external compression on top of that. However, with a clean signal, compression is really, really useful, because as you can see over here, the dynamic range is pretty massive. So it will help even that out a little bit. So I hope that this was helpful, just to give you guys a little bit of information and tips and understanding about compression, what it is, and how to use it as a guitar player. Let me know your thoughts down below. I'll see you soon. Bye.